Hey guys, how's it going? Hey guys, how's it going? Sorry I couldn't be here in class today, so I got this video going, and we're going to cover a little bit about some mass extinction. So get your mass extinction notes out. It should be a single handout that the teacher should have gave you, and like I said, follow along. Just because it's not on the thing, if I write it up on the sheet, it might be important. You might want to write it down. So. I'm going to start these natural mass extinction events with the most recent, kind of moving back in time. So the first one we're going to talk about is the CT or KT extinction event and kind of what happened there. Like I said, this image will be kind of popping in and out, and you'll be able to see me randomly as we kind of go through this presentation.
All right, start the CT extinction event. What do we got to know about it? It happened 65 million years ago. Anytime you see an MYA, that's what you kind of associate with that.
So the first one
basically, what we think happened, it was by an impact event that was several miles wide,
what happened
and it created a crater
this
down
image will be kind of
in
popping
Mexico
in and out,
on the Yucatan Peninsula.
And
you can actually see there's the Yucatan Peninsula where it happened,
this
kind of the event, and this is what it would have left as a result after the impact. Very massive event. Some people think that wasn't the whole story, that climate change, whether it was a gradual change, most likely from volcanic eruptions, specifically from the Indus Decatraps, which were releasing a lot of chemicals at the time, is a possible cause of this extinction event as well. This is also one of those multifactorial events where we think a lot of things factored into killing off the dinosaurs. So what's the damage? Well, marine families, so kingdom family, kingdom, phylum, class, order, family. 60% of families were killed. 47% of marine genre, so genus, species on the scale, were destroyed, and 18% of land vertebrates. The biggest hit was dinosaurs. It basically killed off everything other than everything that was large, which we think would make sense with an environmental impact. Change the environment, less food supply, big things couldn't survive, causing massive damage. Big advantage, by the way, for us mammals after this event. The next one is the end of the Triassic period extinction event. You can kind of see some of the species over here that were impacted by it. Over here, these are some early jawless fish. Today we have the agnathids and lampreys, things like that, that are still around today. But for the most part, they went extinct during this time period. And basically, this event happened roughly about 199 million to 214 million years ago, most likely caused by a massive flood of lava erupting from central Atlantic. Okay, so when this lava is opening up here in the Atlantic, you can kind of see where, if you look at the continents here, opening up, spreading, and causing the Atlantic Ocean actually to form. That volcanism would have raised up, created a cloud around our atmosphere, blocking the sun, causing some major change in water temperature and to species that would have been living on land at the time. This one obviously did have a lot more of an impact on marine genre than the previous. Could be caused mainly by chemicals in the water released by those volcanic eruptions. Rocks from this eruption, which is interesting enough, are found in eastern United States, eastern Brazil, northern Africa, and Spain. As these continents are separating, we get that result. Okay. The vertebrate deaths are unclear exactly how many have occurred. The next one, I kind of put everything in there just so I can explain it. This is the Permian-Triassic extinction, also known as the Big Kill, the Big Kill-Off. It's one of the, it is the most massive mass extinction events that we know of. Some possible causes could have been volcanic eruptions, things like that. A lot of times people, though, associate multi-conditions such as a big gamma ray burst along with some asteroid impact and the climate changes all could be impacted. Biggest thing, look at that, killing 95% of all species. Huge, devastating. This chart I have over here on this side of the board, take a look at that. The PT extinction event's right up here. Usually, by the way, they represent these by the time periods that they begin and end with. Much more massive than any other extinction event known to our planet. Just massive killing off in our planet. One of the biggest things that I just read in this article now that was published in October, article's called Permian Triassic Extinction Event May Have Been Driven by Extreme Weather. And with that being said, they think that extreme weather could have caused the oceans to go all the way up to 104 degrees Fahrenheit. Really warm water, almost like a jacuzzi. Warm water is less oxygen, would have killed off all the things in the ocean, or most of them, 95%. Okay. Once again, the biggest belief is that volcanoes played a huge role in this process. Okay. They found that there could have been as much as 2.7 miles or 2.7 million square miles of lava that was released. So that's about, if you did it, equal to the continent of Australia. Just imagine that much lava being released on our planet. Right after the Permian extinction, there's a nickname for that time called the dead zone. The reason they call it the dead zone is with all these species, it took about 5 million years for species to kind of bounce back or come back to life after that event. So major death, major destruction during the PT, the biggest one of the mass extinctions. All right, Ledovinian time period. This one happened about 365 million years. Some numbers that you need to know. It killed 22%, that's 22% of marine families, and 57% of marine genre, 22 and 57%. We don't really know a lot about the organisms that were on land at the time. There wasn't a lot of evidence. A lot of them were invertebrates, so we don't know actually how it impacted them. But you can kind of see down here, a lot of these species are going to go extinct during the time. Not exactly sure the cause of it, but once again, we think it has multiple effects. Could have been a large collision, and could have been a lot of multiple factors, including volcanoes, gamma ray bursts, things like that. The OS, extinction or Ordovician Silurian extinction event, happened about 439 million years ago. A couple interesting things with that is that we see a real large drop in the sea level. So the cause of this event was that the sea levels dropped down pretty dramatically because glaciers formed. So once again, climate change, rapid climate change affected the environment. But then what's interesting is the sea levels obviously dropped because of the glaciers, but then in a very short period of time, the ocean waters increased. So we have this rapid decrease in the ocean, then rapid increase, and that can really dramatically affect the species living in there with salinity levels, the salt levels, temperatures, things like that. So rapid climate change. Now, what caused that climate change? That's a little bit unknown. All right, 5 main ideas on what caused mass extinction. This is a pretty important slide. And I have here the 5 what we think are the most likely scenarios that cause a mass extinction. Number 1, impact events. Large asteroids, large meteorites hitting our Earth. Not like the one that happened in Russia just a couple of days ago. I'm talking about big, big events. Okay. An impact of sufficient size could create global forest fires and simulate a nuclear winter from the dust it puts in the atmosphere really easily. The next idea would be climate change. Now, it'd be a rapid transition of climate. It's not talking, over 1,000 years, over millions of years. Really quick changes. As we know, species are not able to adapt, evolve, and fit these new species, and therefore extinction event occurs. Now, this is kind of like a secondary impact. What I mean by that is, well, what would cause that climate change? And some of them are natural, but most likely it might have been because of volcanism, because of an impact event, because of a gamma ray burst, or something else that had occurred previously. The third idea is this concept or idea about just volcanoes in general. The Earth is, obviously a lot more tame than it was, but over the course of our history, we have had these major events, and easily could cause mass extinctions. They release a lot of poisons in the atmosphere. They can cause toxic oceans and toxic water that would kill off species. And once again, almost every one of the major mass extinction events, there's some link to asteroids, to volcanoes. Maybe a volcano erupted because of the different plate tectonics, and a major asteroid could actually cause volcanoes, but there is that connection present. The next idea is gamma ray bursts, and basically if from our sun or even possibly a nearby sun, a gamma ray burst could be powerful enough, if large enough, to actually eliminate life on our planet. It could also just destroy our ozone layer. Destroying the ozone allows UV species could go extinct from that. Okay, and statistically, they've said that approximately one gamma ray burst would be expected to occur close to Earth to affect it in the last 550 million years. So just one event probably going to be triggered by a gamma ray burst. The last idea is plate tectonics. Okay, the things that cause earthquakes, the likely event of these, once again, it probably is a multifactorial event, that maybe an asteroid causes volcanoes, some eruptions, and also climate change. They're all kind of linked together. The odds of it being one event are pretty rare.
All right, make sure you pay attention to the last slide in this slide you've got here. Information on there will be on the test for sure, especially these last two slides about the effects of mass extinctions. And then also I will have a matching section on the different mass extinction events and what caused them. So make sure you know those for. All right, make sure you pay attention.
All right, so make sure you guys do know that kind of stuff. Last thing we're going to talk about is the effects of mass extinction. It does take about 5 million years for the world to recover after a mass extinction event. When we talked about the Permian extinction, we talked about how that was a universal dead time. And so it does take a long time. The species that survive, sorry about that,
All
the
right.
species that do survive do tend to kind of take place of the species that went extinct.
Information on there
they
will
take
be
over
on the
those niches.
test for sure.
And adaptive radiation is a key term that we need to know. We're going to talk about several
the
different
effects
examples
of
of
mass
this
extinction.
occurring throughout human history. The first
And
thing
then
I'm going to
also
talk to
I
you
will
guys
have a
about
matching section
is a case
on
with
the
mammals.
different
So a really
mass
good
extinction
example
events
of this occurring
and,
is with mammals.
what
happened
caused
is
them. So make
after
sure you know
the dinosaurs
those
went extinct,
for-
from about 65 to 60 million years ago, mammals were still pretty basic, but then they changed pretty rapidly in that 5 million period, getting us all the species that we know today. Here, I'll show you that here in just 1 second. As you kind of look at this sheet, this is kind of a really cool chart. I mentioned it a bunch. What we're going to talk about with mass extinction is the human. So here is where the dinosaurs went extinct, right there around 65 million years ago.
About the effects of mass extinction.
And what we're going to see is before that
And then
time,
also I will have a matching section
you'll see
on
that
the different
for the
mass
most part, you
extinction
can look at the
events
back of the room with this as
and,
well, what I'm kind of pointing out. Not a
what
lot of
caused
species
them.
of
So make
mammals,
sure you
but
know
within that
those
short period of
for-
time, look at the amount of diversity and species that come around after that time period. A classic example of adaptive radiation. Other examples of adaptive radiation that I have on the sheet, from one original marsupial comes all of the marsupials that we know today. One lineage, several species, classic adaptive radiation. The other one that's on the bottom there can happen on islands. Adaptive radiation is very common on islands, just like the Galapagos. One lineage, huge diversity of life. So it's not just mass extinctions. But like I said, one of the best examples of that is the mammals, because when the mammals were mainly rodents, after that they evolved into monkeys, bats, carnivores like cats and dogs, whales, horses, all appeared in that short period of time. So that's kind of the impact or the effect of mass extinction. Also, you should be able to relate the words mass extinction to adaptive radiation and see the connection between the two. That's all I got. We're going to work on our videos for the remainder of class. The teacher will hand those out to you, and what you're supposed to be working on, those will be due when we come back to school next week.